built up for the fuzzy logic controller based MPPT of solar PV array using a MATLAB. Basically, this is the control system, which is a PV array. This is a fuzzy logic MPPT controller and the duty cycle of DC-DC boost converter, and then the DC load. Basically, the thing is that DC fuzzy logic controller is based on maximum power point tracking. It basically provides the precise and EMI without EMI interference DC output voltage, okay, to the DC-DC boost converter. Then boost converter provides a DC load, okay. So fuzzy logic is one of the main important point to explore the fuzzy logic based MPPT methods. So in this paper, basically we just explore like how fuzzy logic is important for our PCB for our development of solar PV systems. So here is the introduction of the complete ontology. Like it uses the incremental conductance. It also buffer. It also suffer from oscillations, maximum power point, and it use P and O method, like perturb and observe method as well. So basically the fuzzy logic, it handles its ability to handle uncertainties, non-linearities, imprecise inputs, making it highly suitable for real world renewable energy system. So that's why we are using the fuzzy logic controller in with the solar PV array. And yes, I have explained everything in this section, like the introduction. And next part is basically I have written like, see, these are the different voltage, different irritants, different temperature levels of uh, IV characteristics of PV modules basically. Okay, this is the IV characteristic and this is a VR, sorry, PR, PV. This is the power. Okay, so this one is for representing the current and voltage, and this is representing the output power. So in the table I have also added its complete maximum power, rated voltage, its open circuit current, open circuit voltage, temperature coefficient for short circuit, temperature coefficient for open circuit, normal operating cell temperature, and the cell serial modules basically. So I have just explained everything in this report based on the modeling of PV panels, based on the fuzzy logic, and these are the equations I have used in it according to different temperature levels. And these are the charge on PV cells, calculating the charge of current on the PV cells basically. Related work also added in it, like the previous work what is done, and what is our new methodology implemented in it. This is the design methodology, like how PV curve is obtained by varying the irritance and the temperature value. Boost converter is used to boost up the voltage level, like from low to high voltage. Okay, so fuzzy logic is basically, this is a basically block diagram of the designed and implemented PV system. Okay, these are the different fuzzy logic input levels, like how it like for example how it separates the noise level from different voltage levels, different current levels, uh, through membership functions. Okay, and this is a methodology of fuzzy logic controller I have added in details as well. This output is represents the input and output surface waveform of the fuzzy logic controller. And next one is the implementation of DC voltage. Like this is the implementation of fuzzy logic MPPT algorithm for solar PV system. Basically, I have just calculated the output current, power, voltage, as well as maintain the stability at output level. This is the fuzzy MPPT controller is used and a PWM generator also used in it. And this is a technique used in MPPT, like how fuzzy works in MPPT circuits, including different duty cycles. Okay, so this is a voltage of the PV system of output in terms of how it stabilizes the voltage level. Like for example, it stabilizes the voltage level is uh 22, I think. Yes, 22 voltage level. Okay, and this is also the output voltage level after the boost converter. Like it provide us the voltage level is almost 44. Okay, here is the current also, which provide us the complete input and output current of the PV system. Then the power output system. This complete structure provide us the flow control rules of fuzzy logic and its implementation. This is basically the change in output power of PV system due to change in irradiation basically. Okay, output power changes due to irradiation, like intensity of light as well. This is the hardware structure which I have just implemented in the industry lines of our country. So this structure is built. So these are performance indicators which calculated in different times according to different uh, environment. Yes, and next one is conclusion and the references. So let me just provide you the MATLAB project files. These are the MATLAB project files. This fuzzy logic is the FIS file is the main file which you need to run the uh, add this section, and you will get the output results like this. When you will just open this MATLAB file, you will get the output images, and you just need to run to get the output results. Okay, this type of model you will get, and you just need to run it, and then you will get the output results. Okay, thank you.